Grade 12 pre-cal, lesson 6.6, combining transformations of sinusoidal functions. So 6.5, we talked about the different things that we could do to a graph. Now we're going to combine them all together. So sketch one period of the graph 2 sine 2 x plus pi over 2 plus 1. You can see everything is here. We have A, B, C, and D to work with. So one way to do it is, okay, let's graph the original here. As you can see, the original in this case is the black line here. It goes from 0 to 2 pi, 6.28. That's not 2 pi. Well, yes, it is. What's pi? 3.14 times by 2, 6.28. So you'll sometimes see graphs written this way. Okay, what's the range on this one? Well, it's positive 1 to negative 1, right? Now, this has a lot of different things to do it, and a lot of people struggle with this. So what I recommend doing is, let's make a little table of values, of points. So here's our y equals sine x. There's our x values, there's our y. So 0, pi over 2, pi, 3 pi over 2, 2 pi. There's our y values. Now, what happens to everything, the x and the y's? And you got to remember, you have to do your transformations before you do your translations. So you got to do your compressions and expansions before you do your slides or shifts left, up and down, or left or right. Okay, so let's look at this one. Let's do the y value because that's super easy to start with. If you look, there's a 2 out the front, so we take the y value, we times it by 2, and then the plus 1, we shift everything up by 1. That's easy. This one's a little trickier for the x value. The first thing we got to do is that 2 in front there, remember, it's 1 over 2 because it's 1 over b. So we're taking and we're multiplying the x values by a half, and then what's this? X plus pi over 2. What number do we plug in there to make that 0? Well, negative pi over 2. So it shifts it. So negative pi over 2. So then what we can do is we can just go through the x and the y values. Again, let's do the y values first. 0, 2 times 0, 0 plus 1 is 1, right? And you can see the breakdown here. Now, this is a little bit trickier. 0 times, so we're doing this one. A half times 0 is, well, that's easy. That's 0 minus pi over 2 is pi over 2. A half of pi over 2 is what? Pi over 4. Subtract pi over 2 is negative pi over 4. And we can work down through the values. So all you're doing is plugging in the x values. So plug in pi to here. Half of pi, right, is pi over 2. Subtract pi over 2 is 0. Work down, and then you get your points. Now, if you have these points, then you can go back up to the graph and graph them. And you can see, oh, yeah, there's one period. There's the blue line. And that did all the x and y transformations and translations. Nice and easy in the form of a table. It'll get easier as you go along. You'll be able to look at most of these equations and do the math based on that. But for now, try a table of values. Okay, so let's go to next page, and let's go backwards now. So let's determine a possible equation in this form, y equals a sine b, x minus c plus d. That's the standard for sine for the graph here. So, okay, so we're looking at the blue graph here. So I put on the graph here, I put sine, and you can see sine. There it is, and you can see cosine, just to give us an idea of what's going on. Okay, so what we have to do is we have to figure out A, B, C, and D, and well, okay, let's start with period, time to complete one cycle. Well, if you look at this, time to complete one cycle from start to finish is 4 pi, okay? So period is 4 pi, so the stretch has to be a half. So the B value has to be a half based on this because it's a stretch. Vertical translation of -1. Okay, that doesn't make any sense, but what you got to think about this one is you got to look at y equals cosine x. Y equals cosine of x right here starts at +1. So then there is a vertical compression of a half, right? It shortens it up. So then the range would be positive 0.5 to -0.5. And then the whole thing is shifted down 1. So the range would have been 0.5 to 0.5, but then the whole thing is shifted down 1. Remember, your transformations have to be done before your translations. You have to do your vertical compression before you do your shift down. So we have a vertical translation of -1. And there is no horizontal translation because if you notice, it starts at the top and gets all the way back to the bottom. So C is the same. Okay, so one possible way is y equals 1/2 cosine 1/2 x minus 1. So it only happens to 3 things. Now, you can also change that to a sine one. Everything stays the same in the sine, but then there is a horizontal shift 1 pi to the left. It doesn't really matter which way you do it. Probably the easiest way is look at what the graph starts at. If you notice, this starts at the top, so I would work with cosine. If it started in the middle, I would probably work with a sine. Okay? So again, there's your cosine one. Here's all your values based on that. Okay, last example. Okay, if f of x equals cosine of x, sketch f of 2x plus pi. Okay, so let's see what cosine looks like. So our black line here is y equals cosine of x. It goes from 0 to 2 pi, starts at 1, goes down to -1, back up to 1. Okay, now the problem with this one is, if you look at this, It's 2x plus x. So you got to get x by itself. Well, to do that, factor out a 2. So factor out the 2. We've done that on the side. So we take out the 2, right? So 2x divided by 2 is just x. Pi divided by 2 is pi divided by 2. Now what we have is we have a form that we can easily see what we're doing here. So this 2 in front, remember it's 1 over 2 because it's 1 over b. It's half as wide. And this is going to shift it. What number do we plug in here to make it 0? Pi over 2. So it's going to shift it left, pi over 2. So if you wanted to, you could take the original graph and just do that. What do you do first? Do you do your shift or do you do your multiplying by a half? Well, you multiply by the half first and then do the shift. Okay, so if you want to see that in the form of a table, look down here, x comma y. There's our x values, there's our y values. What are we doing? Nothing happens to the y. The only thing that happens is we take the x, right? We times it by a half, and then we subtract pi over 2. There it is right there. 1/2 x minus pi over 2. The x value is the one that's people are going to struggle with because it's always backwards, right? You think, oh, I see a 2. It's got to be 2 times as wide. No, it's half as wide because it's 1 over that value. All right. So then what we do is we take the x values, plug them in, a half times x minus pi over 2. We got our values here, our x values. Y stays the same. Then we can graph it, and you can see the blue one, right? There it is there. If you notice, this one went and stopped and went and stopped because we had restrictions on this, right? Sometimes you'll get them without restrictions, and then you can continue the lines along. But at least do it for one period. Okay? So 2 ways of doing it. Either draw the original, look at the graph, and do the transformations and then translations, or do your table of values.